Hey, this is your favorite German compositor, Sebastian Schitt. Today I would like to talk about monitoring your Nuke script performance with a hidden tool and multiple ways how to access it. Especially during the end of our deadlines, it's important that we have quick turnarounds, and this includes rendering your Nuke scripts as fast as possible. Monitoring your node performance can help you stay in control. I will use quite a bit of Python for it, but there's no need to stop the video. You can download all the scripts that I'm using in this video via the link down in the description below. Please like and subscribe if you've learned something. Are you ready? Let's go! For this tutorial, I'm using a script that I use to explain how lens or focus breathing works in the real world and how we can replicate the effect for our CG or comp elements. Check out my video about transformations if you want to know more about this, and you can also find the link in the description below. There are four main stages of processing a node. First, Nuke stores the knob values that the user has entered and/or selected. Then the node will inform the software about the output it will produce, for example, channels and size of the result. During the third step, the node will request required data from its inputs. And finally, the engine stage. This is where the node generates its output and most of the processing time is spent. That's what we want to measure. Nuke comes with a built-in tool called performance timers. One way to enable this feature is by typing the following command into the script editor: nuke.startPerformanceTimers. This will set the color of all the nodes to gray. Once you hit the play button, Nuke will start color coding nodes, going from green for fast nodes over to orange and red for very slow ones. Additionally, it prints out speed data for every single node. Unfortunately, the CPU information is currently not accurate on Windows and Mac, but the wall indicator is enough for us to judge what's going on in the script. Playing this shot shows us right away that the PG Bokeh node is slowing the script down immensely. Let's see if pre-comping those operations helps. In order to reset our performance timers, we use nuke.resetPerformanceTimers. Let's play it again. Wow, now we see that this area of the comp performs well, but the reformat suddenly turned red. You can see that the color coding is based on the comparison between active nodes, and the reformat node took the lead now. It's resizing my 4K images down to HD. So let's check it again using a pre-comp for this too. Now everything runs pretty smooth. If I throw in an overflow retime, you see how that screws up the performance now. If we want to stop the profiling, we use nuke.stopPerformanceTimers. Performance profiling can also come in handy if you just want to quickly compare different approaches and techniques. On the right, I'm using Nuke's directional blur, rotation and blur strength driven by this controller. On the left, I'm using a hack to fake directional blur by rotating the image, blurring it, and then rotating it back to its original state. That way I can control the blur direction for a simple blur node. Before we have a look at the result, let's make accessing the performance timers more convenient. I create a simple Python panel and assign our three functions from earlier to some buttons. If I add some lines to my menu.py, I will be able to access the panel from the Nuke menu up here. Now let's play the shot. Using the directional blur node can decrease the script performance a lot. Click our reset button and measure the other setup. Look how smooth that is. Alright, let's make the use of performance profiling even more convenient. With some additional Python, I'm adding the panel to Nuke's pane menu. That way it will be accessible from wherever you can open pane panels. The good thing is that way you can even save this configuration as a layout. If you would like to access a node's performance stats via Python, you can do this with the following method: performance info. Of course, you can also run all the nodes of your script through this command. Remember the stages of node processing I talked about earlier? By passing one of those four arguments, you can obtain the specific stats of that stage. If you want to start Nuke with performance profiling activated, just add the flag -p, either in the command line when you start Nuke from there, or you add it to your desktop icon shortcut in the properties. As an additional feature, you can let Nuke write out an XML file during render time. That prints all the data mentioned earlier over the whole render range. In order to activate this feature, you will have to use the flag -pf. followed by the location and name you want to choose for the XML file. As soon as you start rendering from within Nuke, this file will be written out in the background. Alternatively, you can also use this flag for rendering from a command line. Opening this file in a text or scripting editor shows you all the content, but it's a bit hard to look at and difficult to filter out specific data. You can find the render frames in here, followed by the stats of all the individual nodes, including all 4 stages of node processing. I wrote a little Python script that lets you have a look at the values in a slightly more convenient way. You'll just have to pick the XML file location, type in the node name you would like to see the data for, and then choose the stat types. This will print out the responding values for all the render frames, so you can easily see the progress over time and if there are certain frames that cause performance or bottleneck problems. As mentioned, all the Python scripts I used for this video can be found via the link below in the description box. Thanks for watching. I hope this feature will help you to stay more in control of your scripts. My name is Sebastian Schütt, and I'll see you soon.